Hello everyone, I am Dr. Ravinder Gill and welcome to my channel Physics by Dr. Gill. Today we will talk about the principle of least action. But least is an inaccurate word in least action term. It is not generally the case that the equation of motion of Newton or anybody else in classical mechanics tell you about the action, or whatever this term is. We will come to it later on. The action is minimum itself means that the action is stationary. So let's talk about the notion of minimum, stationary and so forth. But first of all, let's talk about the laws of physics, but a special case of laws of physics. The special case of laws of physics is what other laws are determining the equilibrium or configurations of a system when it does not move or it is stationary. Equilibrium means that there are no reason to think that the object moves, and obviously the forces on the object is equal to zero. If we have an object and it does not means, it means no forces applying on it. Let's discuss about it. As we know that the forces are derived from potential, as all real forces are, and the potential energy function V, which is a function or we can say which is a function of collection of coordinates. I am calling here it as x or Vx. Later on we will start calling it Q, but for the moment let's call it x. X can be coordinate of particle, it can be coordinates of many particles. Then the condition is nothing is moving means the force is banished. If nothing is moving, what does it mean? It means force is zero. That I have already told you कि अगर कोई particle move नहीं कर रहा, it means force is banished or zero. Let's first think of the case that the particle is moving in a line. So that what is the relationship between the force and the potential or potential energy? It is minus dV upon dx. So the condition of force is equal to 0. It means minus dV upon dx is equal to 0. It means particle or object is not moving. Or in other way, we can say that the potential energy is stationary or constant. If dV upon dx is equal to 0, it means V is equal to constant. So if you want to draw a graph of a potential, it will be like this. Now let's find where in this graph the force is equal to 0, minima or maxima. So it is equal to 0 at the minima and the maxima, where here it is equal to 0 and here it is equal to 0. Now notice first of all that equilibrium does not require that potential energy is minimum. हमें ये नहीं चाहिए इक्विलिब्रियम के लिए कि potential energy minimum हो, but it requires that derivative of potential energy is equal to 0, or we can say potential energy is stationary. So stationary means that it does not change. If you move slightly to the left, अगर आप थोड़ा left की तरफ जाएं, suppose del x, or this is a right, if you are going to the right or you are going to the left slightly, then the potential energy is stationary or it will not change. So it's another way of saying the derivative of potential energy vanishes. Let's think about a small displacement of x. At the moment, it is not necessary that it is at the minimum. जरूरी नहीं है कि ये यहाँ से डेल एक्स इधर राइट में जाए और लेफ्ट में जाए और मैक्सिमम में हम थोड़ा सा मूवमेंट कर रहे हैं. It is not necessary. We might be anywhere. We can be here, we can be here, we can be here, we can be here. And let's think about how much the potential energy V changes when we move a little bit. अगर हम थोड़ा सा del x मूव करते हैं then potential energy कैसे change होती है. And the answer is dv upon dx times, let's say del x, because the movement कितना है del x है and it is equal to del v. Del v क्या है? This is the या delta v. Delta v is change in potential energy when we slightly move towards the right or towards the left. So the change in v, delta v, when we change a little amount of x, delta x, now what's the rule? The rule is that you are in equilibrium when delta v is equal to 0. Now suppose there are several coordinates, बहुत सारे coordinates हैं, but I am drawing here only 3 coordinates and that coordinates are v, x and y. And how can we draw? Like this. This is the v coordinate, this is the x coordinate and this is the y coordinate. Suppose the potential energy has the shape like this. It has some shape that's a function of position. It's like a hilly train that varies in both the direction. इस direction में भी vary हो रही है और इस direction में भी vary हो रही है. Now, where will the object in equilibrium? Again, in equilibrium, when all the components of force is equal to 0. And that means all of the partial derivative of v with respect to xi is equal to 0. And where is that in figure? It can be here, bottoms and tops of the hills. Now this equation can be written as, जो हमने पहले लिखी थी उस equation को हम कैसे लिख सकते हैं? This equation can be written as, if we move little bit in x direction, del x, then change in v in x direction is del v upon del x delta x. And if we move little bit in the y direction, then change in v will be del v upon del y and delta y. So the total change will be equal to this delta v upon del x, this partial derivative of v with respect to x, delta x, and partial derivative of v with respect to y, delta y, and it must be equal to change in delta v. And the condition of equilibrium is just like the earlier, and that is this delta v is equal to 0 for every possible choice of delta x, delta y, or we can say every possible choice of variation. So we can write the general law of nature of equilibrium is the variation of v is equal to 0 for any little motion and all first order and small quantity. This is very small quantity. So this is sort of summary of all of classical mechanics when the particles are in equilibrium. Of course, we are not only interested in equilibrium, but we are interested in more complicated motions. We are interested in whole trajectories. The problem of finding the functions which minimize some quantity is called calculus of variables, which is very famous branch of mathematics, calculus of variables. The calculation of variation gives us precise analytical technique to find the shortest path, or we can say geodesic, between two given points on a surface. The surface can be any type. And it leads naturally to the Lagrangian formulation of mechanics, from which most dynamical equations of mathematical physics can be derived. Let's find how could we do it. What's the shortest distance between 2 points on space? Suppose this is x and y axis plane, and this is the curve, and this is x1, y1 and x2, y2. This is x and y plane. So what is the shortest distance between these 2 points on space? Shortest means minimum. Minimum means stationary. So one point is x1, y1 and another is x2, y2. And we want a curve which, ये हमने curve बनाया, which minimizes the distance between them. And the curve is defined by some function. And suppose that function is y of x. If we take little incremental distance over here, suppose मैंने यहाँ पे incremental distance x direction में क्या होगी dx, and here in this direction y direction this distance is dy. So the little incremental distance over here is dx. So length of the segment in x-axis is dx and the length of segment in y-axis is dy. So what is the value of this AB? अगर मैं इसको A point दूँ, इसको मैं B point दूँ, और then this will be dx and this will be dy. So according to Pythagoras theorem, the value or length of this AB, which can also be defined as ds, where s is an action, is equal to dy square plus dx square according to Pythagoras theorem. And one can be taken out, और हम क्या बाहर ले सकते हैं इसमें, dy को अगर बाहर लेते हैं then here dx को अगर बाहर ले लेते हैं then here it will be 1 and here it will be plus dy upon dx whole square and outside here it will be dx. So length of the segment, this length of the small segment is called ds. And what's the total distance between these 2 points x1 y1 and x2 y2? What is the total distance? So this distance can be calculated by taking the integral, and S12 is equal to ds is equal to under root of 1 plus dy upon dx whole square integral of with respect to dx. So we can say here that ds define the curve that has the property that its integral, or we can say S define the curve, not ds, S12 define the curve that has the property that its integral along dx of the square root of 1 plus derivative of function dy upon dx, derivative of function, is equal to the shortest possible length, or we can say minimal. To say it's minimal, it means you are at the bottom of something. You are at the bottom of something with respect to any little change. We can write this equation as, अगर हम थोड़ा सा change करें, then we can write this equation delta of ds is equal to 0, or we can say delta of integral of 1 plus dy over dx whole square dx is equal to 0. The analog of being at the bottom of something is always that the variation, this is variation of it, is equal to 0. So the question is, how can we solve the problems like this? In a problem in which you have to find where it is at equilibrium, where the particle is at equilibrium. So to solve the problem like this, an equation like this means that we have to write differential equations similar to the Newton's equations. And Newton equation is, you know, m d2r over dt square is equal to f, and that's one example. This is the one example in which we have find the shortest distance between 2 points, and what we have got that delta of this is equal to 0, or delta of small variation with respect to that curve is equal to 0. So let's talk about another examples and the similar situations. Suppose there is an arbitrary surface of earth, or any train moving on a hilly surface. So it can be like this. Suppose the surface is just like this, any surface. This is not a straight surface, and here are 2 points. One is A and one is B. And we are interested in finding a shortest distance between them, or we can say shortest route between them. Physically, how can we find? What we can do is to attach the string over here and attach the string over here and pull the string. यहाँ पे आपने एक स्ट्रिंग बांध दी और एक यहाँ बांध दी, एंड पुल द स्ट्रिंग एज टाइट, यहाँ स्ट्रिंग को हमने एज टाइट एज पॉसिबल, एंड इट विल डिफाइन सम shortest distance between these 2 points. This might not be a straight line. Why? Because our surface is not straight and surface is curved. An equation can be like this for this, like earlier equation. क्या होगा? The distance between A to B is some integral or sum of little incremental pieces, and the condition that it is minimum or stationary would be that its variation, suppose this is ds and total is s, that its variation between this is equal to 0, जैसे हमने अभी पहले किया था. Delta of ds is equal to 0. Delta integral. Why we have taken integral? Because अगर small increments हम लें और उसे हम add on करें, then it will be integral of ds. Total length will be integral of ds, and variation is equal to 0. So it means it will be minimum or stationary. कब होगा ये minimum और stationary कब होगा? जब ये इक्विलिब्रियम में होगा, और इक्विलिब्रियम में कब होगा, जब डेल्टा ऑफ ds इज इक्वल टू 0. तो इट मीन्स द शॉर्टेस्ट पाथ बिटवीन 2 पॉइंट्स ऑन द कर्व सरफेस इज कॉल्ड, ये हमें पता है, दिस इज कॉल्ड जियोडेसिक. The shortest distance between 2 points on the curved surface called geodesic, and geodesic on the flat plane is straight line. So the principle of least action is that the variation of action, S is an action, variation of action is equal to 0. This is the principle of least action. That's all for today. We have discussed today the principle of least action and try to understand it in a very simple language. In the next lecture, we will try to formulate the Lagrangian for a very basic problems of mechanics. But before leaving, if you have not subscribed my channel, please subscribe the same, as I get motivation to make videos to explain the facts in a very simple manner. If you have any query, you can mail me at email ID given in the description box, or you can also write a comment in comment box. Thank you so much.